Good morning, students. Welcome to the class of fluid mechanics. This is a very important topic as GATE point of view. This topic comes for 4 to 6 marks in GATE examination, and it is very important to learn fluid mechanics as a mechanical engineer. So today we'll start our class with the first topic, which is properties of fluid. So first, fluid mechanics is that branch of science which deals with the behavior of fluids at rest as well as in motion. To start with, if I talk about properties of fluids, basic properties are density or mass density. As the name suggests, density or mass density, here it is denoted by a symbol rho, where rho is mass of fluid by volume of fluid. The unit is kg per meter cube. Second property is specific weight or weight density or weight density. This is specific weight or weight density of fluid is the ratio of weight of the fluid to its volume. It is the ratio of weight of fluid to the volume of fluid. So it comes out to be mass of fluid into G by volume of fluid. So this will come out to be rho into G, and unit is Newton per meter cube. Another property is specific volume. It is defined as the volume occupied by the unit mass of fluid. So it is nothing but 1 by rho, unit is meter cube per kg. Anything which has specific term attached to it suggests that the quantity is divided by the mass. Another important property which you'll encounter many times is specific gravity, also known as relative density. So this property is defined as the ratio of weight density or density. It can be weight density or density because G will get cancelled in this. Ratio of weight density or density of fluid to the weight density or again density of standard fluid. Now here it is important to know that it is a standard fluid. Why I am saying like this? Because Sg for liquids is rho of liquid or fluid by rho of water, whereas S for gas, Sg specific gravity for gas is density of gas by density of air. Okay, so these were the basic properties which you need to know for dealing the fluid mechanics. Now let's start with another important topic, which is viscosity. Viscosity is defined as the property of fluid which offers resistance to the movement of one layer of fluid over another adjacent layer of the fluid. So here it is a property of fluid which offers resistance to the movement of one layer of fluid over another layer of fluid. Now let us understand what it means. It means that, let me take a case where I have a plate, two parallel plates. If I show them in 3D, it will be looking like this, and there is fluid in between. If this plate is stationary and this is being pulled by a force F, I have fluid which is sandwiched in between this. So if I see a 2D diagram, it will be something like this. So I have a force F. Because of force F, there will be certain velocity V of the top plate. This is my top plate obviously, and this is the stationary bottom plate. Now this is stationary, so velocity of the fluid which is near to this surface will be 0. Velocity of the fluid at this point will be V. So as I can see, there will be a velocity gradient or change in velocity with y. So this type of diagram will come into picture, which is known as velocity profile. Velocity profile is the relation between velocity and y. Velocity profile is a relation between velocity and y, where velocity is a function of y. The velocity is in x direction. So let's see, with this plate, if I have a small movement, okay, what has happened? My layer has displaced by a angle delta alpha because of this force. So this J alpha is known as shear strain. This d alpha is known as shear strain. So on the basis of experiments, Newton gave a law for viscosity. He said that the shear stress, that is force per unit area, which is nothing but my shear stress, tau, is proportional to rate of shear strain d alpha by dt. That is rate of shear strain. It is important to know that it is variation with respect to rate of shear strain. Now rate of shear strain d alpha by dt geometrically comes out to be equal to du by dy. So from here I can write that tau shear stress is directly proportional to du by dy. And to remove the proportionality, I put a constant. This constant mu is known as dynamic viscosity. Du by dy is known as velocity gradient. It is the variation of velocity with respect to y. Du by dy physical significance is, if I have a velocity profile like this, where this is my v and this is my y, then slope of